Hello again. Today's topic is going to be dealing with diffusion, and diffusion is something that's really important for you to understand whether you're taking a biology course or my anatomy and physiology course. It's something that we're really going to expand upon, and we experience diffusion every day of our lives, whether it be that you walk out and on a nice spring day and you get all the scents of all the flowers that are blooming, or whether my favorite thing is walking into the kitchen when someone's baking cookies, and those fresh baked cookies really filling up my nose. What's allowing us to smell those things is diffusion. So for example, if someone's baking cookies, you have all of these microscopic really tiny particles of the cookies that just kind of like evaporate into the air, and they're loosened up, and because they're so concentrated in that one area in the oven, they end up actually kind of diffusing out from an area of high concentration to an area of low concentration, and that is the process of diffusion. It's just the movement of molecules from an area of high concentration to an area of low concentration. And so, in order for diffusion to occur, you have to have what we call a gradient. And whenever you think of a gradient, I think of something like a color gradient, which is something I have here on the left-hand side. So right here, I have a box of a color gradient where we have a really dark color right here. And as we move towards the right, it gets lighter and lighter and lighter. What a gradient is basically a difference between two things. And when we talk about a concentration gradient, what we're talking about is the difference between concentrations, whether it be really, really concentrated or if it's just a little bit concentrated. Whatever that difference is, it's what's going to drive our diffusion. So here I have a little goblin, and this is what I like to call my gradient slide. And so I have two slides here, one in green, and I have another one in blue. And of course I have this little goblin that, might like slides, and of course, being a goblin, you would think he's really scary and that he's ferocious, and he would definitely go for that top climb, but he doesn't want to do that. Because he actually is really afraid of speed. And so he still wants to go down a slide. He wants to have a little bit of fun, but he doesn't want to live on the danger side. So because of that, he's probably not going to pick that green slide. So take a moment to think about what is the biggest difference between that green slide and that blue slide. And as you're thinking about that, you probably never noticed that the green slide is at 15 feet, whereas the blue slide only goes up 5 feet, and they both end here at the same point. So they end up at the same point, but the starting point, that difference in height, that gradient is different. The 15-foot one is higher, whereas the 5-foot one is lower. And because of that, if my little goblin goes up, if he slides down the 5-foot slide, he's probably going to go a nice, slow pace, have a little fun, and end up at our finish line. But see, what happens is if my little goblin decides that he wants to come up all the way to the 15-foot height and then slide down, he's probably going to go down really, really fast. Now, think about this. The x-axis, or this horizontal line, that distance is the same, but our rate of change is different. And I know there's a little bit of math term here, but it's really important that you understand this concept of having a gradient, and that varying gradients, those degrees of gradients, especially of concentration, is really going to affect how fast molecules diffuse. Okay, so now let's look at actual real-world implications, not just our little goblin. So here we have the same thing. We have a graph that depicts our gradients, different gradients of a substance A in red and a substance B in blue. And it's the same kind of concept that we have here in the previous one, except this one's green and blue. But you can see that the slopes of those lines are a lot different. And what those are representing, to get a good idea, is if we look here in our red box with the red dots with substance A, And we imagine that there's this membrane right down the middle that allows those molecules to move free across that membrane. We see that we have both substance A in both sides of that membrane, of both sides of that wall. And so what ends up happening is I already do have a little bit, but I have a lot more of substance A on my left-hand side than I have on my right-hand side. And so therefore, because that concentration difference is so great, it's going to move quite quickly. Whereas if I look at the box to the right with substance B, I still have a gradient because I have more particles on the left side of the membrane than I do on the right. And because of that, I still have diffusion occurring, but because that difference isn't as great, the rate of diffusion is going to be slower with substance B. You'll see that again I have substance B particles in both sides of my membrane on both the left and the right, and I do have a gradient, but it's not as great. So I'm still going to have diffusion, but that rate of diffusion is not going to be as significant as that rate of diffusion with substance A. Now, when we talk about diffusion, what is going to be really important is to understand osmosis. Now, osmosis is diffusion. It's a form of diffusion. But the difference here is that we're being very specific. We're not talking about random substances. Diffusion does occur with all types of elements and all types of compounds, but osmosis is very specific to water. So diffusion is the movement of water from an area where there are more water molecules to an area where there are less water molecules. So we are still moving molecules, except now we're talking specifically about water. So osmosis is the diffusion of water.